Now we'll discuss with more details, because you see why I'm spending extra time for this topic, because based on this icon only we have this chapter 5 classification of the air conditioning systems. That says an understanding this is important. So here with the line diagram we'll try to understand all these components. You see, this is a in actual practice you'll find flash chamber, accumulator, and some other devices. At this level, the 4 major components, just to understand the concept. Okay. When we deal with the classification of the air conditioning machine, you'll find more details. At this level, just focus on the concept. So the 4 major components, one is a compressor. Second, this heat exchanger is called condenser. And this heat exchanger is called evaporator. And here you'll find expansion device. It can be a throttling valve, it can be a capillary tube. You'll find the different types of expansion valve. Okay, so at this level, just focus on the concept. So the cycle start from compressor, right? And if you consider this high and low side, you see the compressor and condenser comes under high side, and the expansion and evaporator comes under low side. Low side, high side means I'm talking about the pressure and temperature. Suppose if you draw the line, so you see the left side is a high side and the right side is a low side. Okay, so now with respect to the theory which I've given in the notes, let me mark the points first. You see here the points are given, but before this, quickly some more points I added. You see the Vapour compression cycle is based on the principle that a refrigerant can change from a low temperature vapor to a high temperature vapor, changing its state through compression and expansion. We'll discuss how exactly. And remember, it's a closed system. So what is the difference between closed and open system online?
Closed means loop system. Refrigerant will not flow. Refrigerant will.
You see, technically, with respect to thermodynamics, closed system means only the heat can transfer the system, not the mass. In case of open system, the mass and heat both can cross the boundary of the system, but closed system, only the heat will transfer, the mass will not transfer the system. It means, you see, in this cycle, the refrigerant is running within the cycle now, it's not coming out from the system. Only the exchange of heat. So we can consider this as a closed system. And it's used as a refrigerant. And what is refrigerant we already discussed. So now you see point 1 to 2. Let me mark this point so that you will get the clear idea. Point 1 to 2, leaving the evaporator. The refrigerant at the low pressure and low temperature and pressure, it uses again to achieve the refrigerant effect continuously. So point 1 to 2 here is related to, you see, 1 minute. Just let me mark this so that you will not get the confusion. You see condition at point 2. Condition at point 2 means we require a high pressure and high temperature. So let me mark this first. Avoid confusion, or else without marking also we can learn, but the theory to avoid confusion which I've given in the theory, I'm going to mark. You see, I'm considering this point as 1 and this is as 2, and before expansion I'm marking this as 0.3. After expansion I'm considering this as 0.4, then again 4 to 1. You see the cycle is 1 to 2, 1 process, 2 to 3 is a process, 3 to 4 also a process, and 4 to 1 also a process. Okay, so with respect to these points we'll discuss, and it's very easy. You see the cycle starts from the compressor, and remember, in compressor you'll find the refrigerant in what state, liquid or gas?
Gas.
So remember, refrigerant in compressor, refrigerant you'll find in the gas state only, because the compressors are designed to handle the refrigerant in the gas state. First point. And second point, what do you think? Liquid and gas both are compressible, or only gases are compressible? Yes, online. If you compare, you see, if you compare liquid and gas, comparatively gases are more compressible, but it not mean that liquids are not compressible. Liquids are also compressible, but very less compared with the gases. So that's the reason in actual practice, just we are considering gases are compressible, liquids are not compressible, but liquid also slightly compressible, but under high pressure. So even liquid also compressible, but practically we are considering the gas are compressible. So inside the compressor, the refrigerant should be in the gas state, because we are considering gases are compressible. And when you switch on the compressor, how we can switch on the compressor? By supplying the electrical energy. Na? For example, when you plug in or when you supply the electrical energy to the compressor starts. You may find the different types of compressor that we'll discuss later, like centrifugal, reciprocating, etc. that you'll find at the time of classification of machine. And at this level, you know what is that compressor? Compressor is used to compress the refrigerant gas state. So when the compressor compresses the refrigerant in gas state, what will happen to the volume of the refrigerant? Increases or decreases? The volume decreases. And what will happen to the pressure? Increases, right? And you know this, I think you're already aware of this. Pressure is directly proportional to temperature or inversely proportional to temperature. Pressure is directly proportional to and you can relate with this concept of temperature. We discussed now temperature is a function of movement of molecules. As the movement of molecule increases, the pressure, the temperature increases, and the movement of all molecule related to the pressure. So it means as the pressure increases, the temperature also increases. So remember, pressure and temperature are directly proportional. So volume decreases because of compression, and the pressure increases. And as the pressure increases, temperature also increases. Actually, our requirement is to increase the pressure so that we can run the cycle. But since directly this pressure is directly proportional to temperature, the temperature also increases. So how to reduce the temperature? We'll discuss. So you see, the compressed refrigerant in the gas state with the high temperature and pressure, you can see high pressure and high temperature in the vapor come out from the compressor, right? So in order to reduce that pressure, in order to reduce the temperature, first of all, you must change this vapor to the liquid. So what will happen? The refrigerant, which is with a high pressure and temperature, we are supplying to a heat exchanger called condenser. The name will give you the idea. The condenser means condensation will happen inside this and change of phase from vapor to liquid. So when the refrigerant entering in the condenser in the form of vapor with a high pressure and temperature, so you see it will flow inside this tube, and it's a heat exchanger. So what will happen in the heat exchanger? The heat exchange from this refrigerant to outside, and this exchange of heat can be done with the supply of air. For example, I'm using a fan here, and this fan, when you run the fan, it will suck the air from the outside and is going to throw on this, and you see the outside temperature compared to the refrigerant temperature, it should be less, and it's a high temperature pressure. So assume that the supply air what I'm throwing on that coil is a less temperature. So heat transfer from high to low as per the second law of thermodynamics. So what will happen? This air is responsible to reject the heat off from this refrigerant, which is in the gas form, equal to what? Equal to latent heat, because the vendor, means the manufacturer, will design this condenser, this heat exchanger, to reject the heat equal to the latent heat. And whenever the latent heat, it means when the rejection of latent heat, what will happen to the phase?
Gas to liquid.
Yeah, change of phase. Na, latent heat means change of phase. So what will happen? The inlet in the condenser is in high pressure and temperature vapor, and because of the heat rejection to the atmosphere by using the air, so the outlet of this condenser will get again high pressure, high temperature, but in liquid. You see, you know this change of phase means latent heat at what? At constant temperature, na? So temperature is still same, but change of phase in the condenser.
So, one question is:
Yes.
This fan is this much of accurate that it can only lower the temperature, not lower the temperature,
Rejection of heat.
Rejection of heat, so that
you see, according based on that only the manufacturer is going to design this, the flow rate of air, the number of coils, the thickness of the coil, dia of coil, then only the system will work. So that is again the component designing. So the manufacturer will design the condenser so that it can able to reject the heat equal to, means not less than equal to this latent heat. Then only the change of phase is possible, right? So that
temperature will be remaining same.
Temperature and pressure both is going to be same, but change of phase, because at means latent heat means at constant temperature, na? Okay. So when the refrigerant is coming out from the condenser, it's with the same temperature, pressure, but it changed from what? Vapor to the liquid. Okay. And here one more important point: if you use this fan to cool the condenser, so remember this system, and you can write as a note also. If you want, you can please make a note. This is a very important point. So when you cool the condenser by using a fan, so this system we can call as a air cooled system. And when you cool this condenser by using water, for example, I'm using a separate container, and this complete coil inside the container, and I'm going to supply the water. Suppose here water in, I mean H2O in, and here suppose this H2O out, means I'm circulating the water on the coil, and the water is responsible to reject the heat of that condenser. So remember, this system will become water cooled condenser. And why I'm explaining this point, because at the time of learning chill water system, means I'm talking about chiller. Chiller is of two types. One is a air cooled chiller and second is a water cooled chiller. And in air cooled and water cooled chiller, only the difference is at condensing site. Rest of the thing is same. So in chapter 5, we'll discuss in detail about the chiller. Don't worry. But I'm just relating because this is an important point. So at this level, just remember, if the condenser is cooled by air, we are calling that system. It can be a chill water system. It can be a different system. All comes under DX. We'll discuss in chapter 5. So the system we can call as air system, air cooled system. If I'm using the water to cool the condenser, that system we can call as a water cooled system. Next. So now you see outlet of the condenser, it is in the refrigerant, it is in the liquid, but still with the same temperature. We are interested to reduce the temperature. So now you see process 3 to 4. So now this refrigerant in the liquid form is allowed to pass through a device called expansion device or expansion valve. It can be a throttling valve or it can be a capillary tube, etc. You'll find the different types in actual practice. But at this level, just focus on the concept. So remember, expansion. With the expansion device, what will happen? Expansion process will take place. An expansion is a reverse of what?
Compression.
Yes, exactly. So because of expansion inside this, excuse me, because of expansion process of refrigerant in the liquid form, what will happen to the volume? The volume increases and pressure decreases, and pressure is directly proportional to temperature. So temperature also decreases. Okay. And you see, when the refrigerant is coming out with the low pressure after this expansion process, the pressure is so low, some amount of refrigerant flashes and change to vapor, some amount, by extracting the heat from the remaining liquid refrigerant. And we know that as the pressure decreases, the boiling point of the substance also decreases. So at the outlet of the expansion device, some amount of water, some amount of refrigerant will flash and extract the heat from the remaining liquid refrigerant. Further, it's cooling down, means extracting the heat. And this cool, you see, at the low temperature and pressure refrigerant, when coming out from this expansion device, the outlet of the expansion device is connected to the inlet of one more heat exchanger called evaporator. This is the application site. Okay. So this evaporator, if I use to extract the heat from the food product, this system I can call as a refrigerator. If I use this evaporator to extract the heat from the room air, this I can call as a air conditioner. Or if I use the same to extract the heat from the water, I can call this as a water cooler. I'm not talking about air cooler, that is different. Water cooler, you'll find the water cooler also only to cool the water. You'll get the chill water from that for drinking purpose. So you see, application, we have different application, but the concept is same. So this heat exchanger is called evaporator. So remember, when the low pressure and temperature refrigerant entering in the evaporator, so what will happen? Because of low pressure, the boiling point of that refrigerant also reduces. Means it can start boiling at the low pressure when extracting the heat. So what we'll do, we'll use a fan. For example, I'm taking example of air conditioner. I'm using a fan, and this fan is used to suck the air from the room. And suppose room temperature say 30 degrees centigrade, and this refrigerant temperature say 5 degrees centigrade. For example, or it can consider say 15 degrees. It's depend as per the capacity and other factors. Just for example, so you see 15 degrees temperature is less than 30. So when the 30-degree air is going to throw on this coil, and remember, the air is not going to mix with the refrigerant. There is no mass transfer. So this is a copper tubes, and copper is a good exchanger of this is a good conductor. So what will happen? You'll get the this temperature of that surface of that copper tubes will drop. Means you'll get the cool copper tubes when the air is thrown on that coil. Okay, on that cooling coil, what will happen? The air heat will extract by the refrigerant. Right? Because again, second law of thermodynamics, heat transfer from high temperature to low temperature. So the refrigerant will extract the heat, and the refrigerant at low pressure means at low boiling point. So it start boiling, and start boiling means it will extract more and more heat. And when the refrigerant is coming out from this evaporator, it will change its phase from liquid to vapor by extracting the heat equal to latent heat. Again, the manufacturer will design this evaporator to extract the heat equal to latent heat. Then only the change of phase from liquid to vapor, means gas, And now at the outlet of this evaporator, the refrigerant condition is what? Low pressure, low temperature, but
Vapor.
in vapor. Again, that low pressure and low temperature vapor, in order to circulate again, we required a system, na? Again, the compressor. So the low pressure and temperature vapor means gas will suck by the compressor, and again the compressor will increase the pressure and temperature. The cycle continues. Okay, so in this way we'll get the cooling effect, and this cooling effect you can utilize for different application. Based on different application, we are dealing with the different, we are calling the different system. Again, further, if you talk about air conditioning, in that also you'll find the different system, like DX system, or chill water system, or air system, etc. We'll discuss in chapter 5. And
So
in actual practice, you'll find here one accumulator, because this accumulator will not allow any refrigerant liquid in compressor. It will bypass back to the circuit. Similarly, you'll find the flash chamber also here. If any gas is in that, it will supply back to this. So in actual practice, you'll find additional components also. Apart from this, you'll find the receiver, because the refrigerant after expansion, it is collected in the receiver, and as per the requirement, it will supply to the evaporator based on the demand. So you'll find a number of components in actual practice. At this level, just focus on the concept, how we are getting the cooling effect. That's it. Yeah. So now if you have any question, we can discuss.
Sir, if I'm summarizing the thing, after expansion valve till the section of compressor, pressure and temperature will be same, right?
Yeah, but you see, outlet of this expansion, it is in
Outlet.
refrigerant in liquid. Outlet of
Only the phase change will be occur
yes,
in the
yes.
evaporative coil.
And the same
And
case on the high side also.
temperature and pressure will be same, but phase change will occur in the condensing coil.
Yes. So
And then
just go.
accumulator is means sorry, receiver is the after the condenser the liquid
After evaporator. Sorry, oh, my mistake. After condenser.
after condenser.
You'll find this accumulator. Sorry, my mistake. This receiver, accumulator, this of evaporator, and flash chamber after this condenser. The flash chamber will not allow any gas in the expansion. Accumulator will not allow any liquid in the compressor.
Because it's vapor compressor. I think compressor will be damaged.
Yes, definitely, because compressor is designed to compress the refrigerant in gas state. Okay. Like this, you'll find some more options like controls, etc. in actual cycle that will I'll show you in chapter 5 at the time of dealing with the Windows split or other systems. Okay. But the important point is, if the condenser is cooled by air, it's an air-cooled system. If the condenser is cooled by water, it's a water-cooled system. Please make a note of this point. We'll use at the time of chill water system also. Apart from this, how the phase change and how this cycle, different process like compression, condensation, and expansion and evaporate. This 4 process, and I've given the point also 1 to 2, 3 to 4, and 4 to 1. The same with reference to that, you'll find the theory in the notes. So this conclude the vapor compression cycle and chapter 3. In the next session, we'll start chapter 4. That is psychrometry. Very, very important. Psychrometry means the property of air. Air means the moist air. And without learning the psychrometry, you cannot think for this designing, or you cannot think for this load calculation. Means conditioning of air, because with the psychrometry you'll find the properties of air. Okay, then online done for tonight. Thank you.